Hello, good afternoon. My name is Veselin Pizurica. I'm a CTO and co-founder at Waylay. And today I'll be talking about how we approach data science at Waylay. Company was founded back in 2014, and I can say today we have more than 50 enterprise customers from Australia, Japan to Europe and US. We are a B2B software company, and typically our solution is embedded in the customer solutions as the OEM solution that we sell to our customers. And typical markets in which our customers are working, it's industrial automation, building management, HVAC manufacturing, and so forth. So what actually our platform enables customers to do is to interconnect IoT systems, such as sensor networks, LoRa networks, machines, together with IT data sources, such as the databases, ERP systems, Salesforce, and so forth, and then benefit from our technology for end-to-end automation, where we bridge, if you like, these two worlds together, and as well provide very powerful analytics solutions on top of that, together with the customer-facing dashboards and visualizations. The benefits of using our solutions is that our customers can really have extremely fast time to market. It's ideal tool chain to productize deep domain expertise on industrial processes and machines. We support, really, I have to say, that unlimited number of use cases, and we'll see through this presentation some of these examples where our customers can leverage and benefit from the low-code automation, analytics, microservices that we provide for them. And as I mentioned early on, our technology is often white-labeled, and it can be deployed in the customer clouds, can be Azure, AWS, Google, or even in their own data centers. So what our customers are typically using Waylay for condition monitoring, remote diagnostics, facility management, predictive maintenance, alarm management, equipment as a service, service optimization, energy efficiency, and data quality validation. Our approach, or other customers' approach to these tasks using our solution, if I look back, I would like to categorize them in 5 different ways of doing if you like, the automation. One of them is a classical expert domain modeling, where customers build the rules with a clear indication of the issues and remedies, or create the rules which are based on the relations between entities, which is often the problem in industrial setting, where you retrofit through the sensors machines, but each of these sensors has a different role and different measurements. Then you have obviously classical approach for anomaly detection and predictions using the time series analytics. We often see also customers having their own domain knowledge, already data scientists, which have models written in Python or other languages, which would like to embed in our solution. And finally, there are customers who have their own offline analytics and data mining tools, and they would like to continue using these. So let me start with the first category, when experts are modeling their knowledge and apply them to, in different settings, to the data logs, store data, or stream data. And these rules are typically easy to interpret, and sometimes explainability is important. And I will show now in the next couple of slides how our customers are building solutions using this approach. I will start with something rather simple to explain, which is connected appliances which are already giving error codes. But what is the problem here is that you would like to interconnect this information together with the overall support systems, emails, ticketing, call centers, and so forth, in a simple, robust, and a scalable way. The second example is what we can share, because it's a publicly available knowledge or a document rather from the Australian government on the energy efficiency and of course trying to be more energy efficient. And one of customers of ours, it's actually mentioned this report. For instance, Melbourne Museum is managed by our automation technologies, and you see here one application of the rule which works either on the streams or the data logs, through which the customer was able to save about $200,000 a year. As I mentioned earlier, sometimes we like to think about IoT as a connected devices. Let us not forget that majority of the appliances are not connected, but they are producing the logs. And in that particular case, or if you have a devices behind the VPNs, is the same problem. You still like to benefit from the cloud technology and automation. Having said that, you have to collect logs and then run them against the rows. Another typical problem is that in industrial setting, you do the retrofitting of devices. Here I'm going to show you just example of our customers who is in energy market, who has put a lot of sensors on different places inside the energy cabinet. Quite sophisticated rule. Each of these sensors is monitoring a different place in the cabinet. And what you would like to do on top of that is to actually provide an easy monitoring, visualization, and alarm system. Now, it is very important that at any moment in time, you have to go back to the live system, understand if there is issue, and if there was an issue, why the alarm got triggered. As I mentioned earlier on, retrofitting, typically industrial settings, people talk about private LoRa's or Sigfox, and this is example from our customer who managed literally within a week or two to implement end-to-end solution using our technology. And this is actually a demo setup of our customer, where they basically place the sensors in a different places within the machines, and then on top of that build very easy customer-facing dashboards. And this is basically something that they're very proud of mentioning publicly, that literally within 3 weeks, they managed to create a solution end-to-end. In this particular case, it's something about heat exchangers and coolings. The other aspect of using our system is to use a classical approach of the machine learning, where we provide off-the-shelf models and training capabilities so that you can actually benefit from existing algorithms. Typical use cases here are anomaly detection. There's something that does not follow pattern that was expected to see based on the training data, or prediction for the future energy consumption use cases. Just one example from our customer who is using this tool to basically look for the anomalies. And it is often the problem that you have a lot of false positives. So you rather need to look at not only the energy consumption and seasonality, you also would like to combine this with what you call exogenous values, weather forecast, holidays, and other information in order to avoid false positives and provide robust anomaly detection algorithms. As I mentioned earlier, some of the customers have already something in place, but they would like to benefit from our application and use still the automation technology to combine that together with SAP and Salesforce and so forth. And in this particular case, what happens is that our customers are taking the data out, training their models in the Python, then deploy these models back in our system, and then benefit again from our automation technology. Example from one of our customers in HVAC space, where they're training the models using the Python books. Then they can verify these models against these machines and others in the system, and then eventually build the models, deploy them in our system, and interconnect that with all sorts of other applications and CRM systems. Finally, the one that we often talk about when we talk about AI and ML, which is the first thing that people have in mind, is to use the offline analytics when you have a data stored and use the pipelines. And like I mentioned earlier on, we can peacefully coexist with all other applications which are already on the market. This is an example of how customers are using our system together with the Google pipelines. And one example from the traffic use cases that we did for the Belgium roads. Here you have the impact of the COVID on the traffic in Belgium. You see obviously a drop in the traffic after the lockdown. And again, you can take your Python notebook, load it, and understand the analysis of the traffic patterns as it's going from 1 hour to the other one, or from one day to the other one. The same with the Tableau. And you can apply the same rules for the energy efficiency, anomaly detection, predictions, or infrastructure planning, and so forth. With that, I would close my application. I would like also to thank my team, which is growing. And this is already outdated pictures only for a couple of weeks ago, and we're already having another 5 colleagues join our team. With that, I would close. Should you like to know more, please go to our website or just send us a request for a demo. Thank you very much.